Hey everyone, and welcome. Have you ever really stopped to wonder how a computer program actually remembers anything? Well, today we're going to dive deep into the absolute bedrock of Java programming, variables, and how they let us store and manage information.
I mean, really, it all boils down to this question. When you're playing a game and it keeps track of your score, or you log into a website and it greets you by name, how does it hold on to that info? The answer, and the foundation for everything we're about to talk about, is the variable.
So, let's start at square one. What exactly is a variable? Honestly, you can just think of it as your program's short-term memory. It's the most fundamental tool we have for storing any piece of data. The best way to picture it is like a simple container, maybe a jar, with a label on it. The label you write on the jar, that's the variable's name. And whatever you decide to put inside the jar, that's its value. It's a beautifully simple concept that lets us name a piece of data, store it away, and then grab it again whenever we need it.
Now, actually using a variable is kind of like a two-step dance. First, you have to declare it. This is you creating the empty jar and slapping a label on it. You're essentially telling Java, hey, set aside a spot in memory for a number, and let's call it age. Then you initialize it. That's the part where you actually put something in the jar for the first time.
Okay, so we've got our container, but it's not enough to just have a jar. Java is pretty particular. It needs to know what kind of stuff you plan on putting inside. This is where data types come in, and in Java, they're pretty much split into two big families. And this right here is a really crucial difference. On one hand, you have primitive types. These are the simple, no-nonsense guys. They hold the actual value, like the number 10 or the letter C, directly inside them. They live in a super organized, fast part of memory called the stack. Then you have reference types. These are more indirect. They don't actually hold the data. Instead, they hold a memory address, basically a little pointer that says, hey, the complex object you're looking for, it's over there, pointing to a more flexible memory area called the heap. And here they are, the 8 basic building blocks of data in Java. Now, while you have all these options, let's be real. In your day-to-day coding, you're mostly going to be using int for whole numbers and double for decimals. Boolean, of course, is your go-to for simple true or false logic. The others, like byte and short, they're really handy when you need to be super efficient with memory, like when you're dealing with huge amounts of data. Okay, now we're getting to the really good stuff. Where do these variables actually live, and how long do they stick around? This concept is called scope and lifetime, and I promise you, understanding this is the key to dodging a ton of common programming bugs. First on the list, local variables. Think of these as temporary workers. You create them inside a method or some other block of code. They pop into existence when the block starts, they do their job, and then, poof, the second that block of code finishes, they completely vanish. You can't see them or touch them from outside their little home. Next up, we have instance variables. These are totally different. They define the properties or the state of an object. So if you had a person class, things like name and age would be instance variables. And what's crucial is that every single person object you create gets its very own separate copy of these variables. Changing one person's age has absolutely no effect on anyone else's. This is a perfect example to illustrate that. Here, width, height, and depth are the things that define what a box is. Every single time we create a new box object, that new object gets its own personal set of these 3 variables to hold its unique dimensions. And finally, there are static variables. The most important word to remember here is shared. Unlike instance variables, there is only one single copy of a static variable, and it's shared among all objects created from that class. So if you had a counter class with a static count variable, every new object would be looking at and changing that exact same single value. It's like a shared resource for the whole class.
Okay, so we've covered the fundamental rules. Now let's switch gears and talk about a pretty cool modern feature that was added to Java to help us write cleaner, more readable code.
And you don't have to take my word for it. The folks at Oracle who actually make Java said it best themselves. Sometimes the old school way of declaring variables can get really repetitive and just clutter up the code. I mean, take a look at this. We have the type name URL on the left and then again on the right. Same thing for URL connection. We're saying the same thing twice. Yeah, it's very clear, but it's also just noisy. And here is the solution. the var keyword. When we use var, we're basically telling the Java compiler, hey, you're smart. You can see what kind of thing I'm creating on the right side, so you just figure out the type for me. All of a sudden, the code is way cleaner and less cluttered, and we haven't lost any information. This is called type inference, and it's awesome. And just a quick nerdy side note, var isn't a true keyword like int or class. This was a really clever design move. It means that old codebases that might have used var as a variable name wouldn't just explode and break when they were updated to a newer version of Java. All right, let's bring all of this home. Because knowing the rules of the language, the syntax, that's just step one. Using those rules to write code that's elegant, clear, and easy to maintain, well, that's a whole other skill. It's about developing good style. So here are some really solid guidelines. Always try to declare a variable as close as possible to the first place you actually use it. It just makes code so much easier to follow. Keep your variable scope as small as you can. This helps cut down on complexity. And for the love of all that is holy, use descriptive names. Total volume is infinitely better than TV. And finally, use var wisely. It's a fantastic tool for readability, but not if it makes the code's intent less clear. You know, the really crucial takeaway here is that variables aren't just about storing data. Every choice you make, how you name them, where you declare them, how you scope them, it all has a massive, direct impact on how easy your code is to read, to debug, and to maintain down the line. Ultimately, it really makes you think about our craft, doesn't it? Are we just writing commands to make a computer do something? Or are we trying to build something that's clear, elegant, and understandable for the next human who has to look at our code? Every variable you write is a small part of that answer. Thanks for joining me.